Hello everyone! Today we are going to learn a new rule that is called the chain rule. This rule is very similar to the power rule, but the power, instead of affecting just an x, it affects an entire binomial. For example, we know that if we have x squared, we can apply the power rule. But what happens if instead of having just x squared, we have x plus 2 squared? So now this squaring here is affecting not only the x, right? Not only the x, but also the number 2. So let's see what happens. So let's write the formula first. The formula says dy over dx of un equals to, you know that every time that we have this power, it goes here down, multiplying the u, right? In the power rule, we apply this. We are going to apply this in the chain rule as well. So it is n multiplying u to n minus 1. Yeah, so it is very similar, but now what's the difference? The difference is that we need to multiply this times the derivative of the u, like this. So it is the derivative of all the binomial, like all of the outer term, times the derivative of the inner term, the one that is inside the parentheses. Let's answer these two examples that we have in here to see how it works. So if we want to get the derivative of x squared, once we apply the power rule, we know that this equals 2. This goes multiplying the x, and we subtract 1. So we'll have 2x, right? 2 minus 1 is 1. We have the 1 in here, but it's not necessary to write it. It's okay like that. What happens in the other one? Well, we are going to do the same thing. This 2 goes here down, multiplying the binomial. And we say 2 times x plus 2, and we subtract 1. So it is 1 in here, but same thing, it's not necessary to write it down. And this times the derivative of the inside. In this case, we have the derivative of x, which is 1, and the derivative of 2, which is 0, so times 1, right? And now we multiply everything, and we have 2x plus 4. And this will be the answer. We can prove this by solving the binomial square. I'm gonna erase a little bit this. So we know that if we solve the binomial square, we will have something like this. X squared plus 4x plus 4, right? I'm solving this one in here. Oh, this one. So if we get the derivative of this in here, we can apply the power rule, right? And now our derivative will be, this goes down, we subtract 1, so we say 2x plus 4, right? So as you can see, we have the same answer as this one, because it is the same binomial. So these are two different ways of solving it, but not all of the binomials can be solved in this way, because not all of them are square or have a square power. Let's try to solve another one, a harder one. Let's see. Oh. So imagine that we have f of x equals to x squared minus 1 to 4. Yes, so we cannot apply the power rule because this 4 is affecting the x squared and is affecting the minus 1 as well. So in order to answer this, we need to use the chain rule. So we apply the formula, this goes down, and we say 4 x squared minus 1 third, this is minus 1, multiplied by the derivative of the inner term, which is 2x. Okay, now what? This number and this term can be multiplied. So we need to multiply them. So we say 4 times 2x, 8x, times x squared minus 1 cubic. Yes? And you don't need to develop this one in here. It's not necessary to develop it, because it will be very, very long. It's okay to leave it like that. Yes? So it means that this is our answer. And that's it. Okay, so now, if you have any questions here, please pause the video and raise your hand. If not, let's continue with the explanation, doing some examples. Okay, so I'm going to raise here. There it is. What if we have something like this? So we know that in order to solve this, we can use the quotient rule, right? And we will have our answer. But we can also use the power rule to solve something like this. And, well, I would say it's easier to solve it with a chain rule. So we know that this is the same as having this, right? So one class we said that we cannot have this term, or we cannot apply the product rule in this term because of the minus 1. And that's true, because we need to apply the chain rule now. But now that we know it, let's try to answer it like this. So we say y prime equals 2. Remember, first the outer term, this goes down, minus 1. So we say minus 1 x minus 2 minus 1 minus 1 minus 2 times the derivative of of the inner term there, which is just dx. And in this case, it is 1. Once we multiply this, we get minus, well, if we multiply 1 minus 1 times 1, it is minus 1. And remember, you don't have to really write the 1 because it is a multiplication. So you can write it like this, minus 2. But we have a minus 2 in here as a power. It's negative. So it means that we need to change this, right? This needs to go in the denominator, in the fraction. So we can have minus 1 over x minus 2 squared. And this in here will be our final answer. Okay, so now I want you to pause the video and answer this same exercise but using the quotient rule. Once you finish, raise your hand and show me your answer, and let's compare this chain rule versus the quotient rule when applying to a problem like this one. Okay, so let me erase this and let's continue. Okay, so what happens if we have trigonometric function? For example, sine f of x, sorry, equals sine of x. So we have seen these formulas and we have seen this kind of functions, and we say that the derivative of sine is cosine, right? And this will be the answer. But we have only seen the trigonometric functions that have the x alone, but it can be 2x, 4x squared, etc., right? So let's move it, or let's change this problem and let's make it harder. So for example, f of x equals 2 sine 4 of x of 2x. Okay, this is too difficult. Let's change it like this first, and then we check the other one. Okay, so we know the derivative of sine is cosine, but as you can see, we have a 2 here inside the angle, right? So we are going to apply the same thing, the chain rule. Okay, so we are going to get the derivative of everything, we can say, of the outer term times the derivative of the inner one, which is 2x. And if we solve this, we say the derivative of sine of 2x, which is cosine of 2x. And this is multiplying the derivative of 2x, which is 2. Yes? Now if we multiply, be careful, be very, very careful in here. You cannot multiply this times this. You cannot do it because this in here is the angle of the cosine. This is just a number. But you can write it in a simpler way, and this will look like this. This 2, we move this to here. Cosine of 2x. Okay, so now you know that this 2 is multiplying the entire cosine, including the angle. If you have questions in here, please pause the video and raise your hand. If not, let's continue then. Okay, let's try the other one that I wrote, which was sine fourth of 2x squared, let's say. No, it's okay like that. 2x. So, remember this goes here in the middle, but this is part of the sine because it's its angle. So this form, you can also write it like this. Okay, this form, this one in here, this one is like the correct way of writing it, not just in parentheses and stuff, but you can also write it like this, and it is correct. It's the same thing. So how are we going to answer this? So we say, let's write in here. Okay, so first we need to get the derivative of the outer term. Remember, this 4 goes down and we subtract 1. So it is 4 sine of 2x to 3. Yes, it is cubic. Times the derivative of the inner one. But as you can see, we have two different, or not different, but two chain rules in here, right? So we have applied one, and inside we have also a chain rule because of these two that we have in here, right? So we say the derivative of the sine of 2x, which is cosine of 2x, and this is multiplying the derivative of 2x of the angle, which is 2. Okay, so it goes from the outside, from the bigger derivative, to the inside, to the smallest one. And if we move this, or if we multiply and we apply algebra and everything, this is going to look like this. So we have 4 sine cubic of 2x. Remember that the power goes in the middle, times 2 sine of 2x. And this in here will be our final answer. Okay, let's try another one like this because it was kind of hard. So let's try another example. Okay, so we have x cubic minus, now instead of having sine, we're having cosine. Cosine cubic of 6x. Okay, now this looks like this. Well, parentheses are not really necessary. It can look like this and it's correct. Okay, so as you can see, we have here two different rules because of the minus. Well, more than two actually, you have three. We have the power rule in here. We have a trigonometric one in here. And because of these three, we have the chain rule as well. Okay, the 3 and the 6 actually. So, how are we going to answer this? Okay, we first answer the power rule. 3x squared, right? Minus what? We can change this if you prefer. You can write it like this if you want to make it simpler. Yeah. So remember, first the bigger term. So we have 3 cosine square, because it's minus 2, of 6x. And this in here is multiplied times the derivative of the inner one. And in here we need to apply the chain rule as well, because of the 6, right? So we say the derivative of cosine, which is minus sine of 6x multiplied times the derivative of the 6x, which is just the 6. And it looks like this. Now we need to apply algebra. So we have 3x squared. Okay, this term in here and this term in here are multiplicating. Okay, so minus times minus, and we have a plus. Plus 3 cosine square of 6x. Wait, sorry. Yeah, we can put here a parenthesis because of the 6 that we have in here. Yeah, or not in there. It can be also just like here. Yes, just to identify which one is the number and which one is the angle. And this 6 sine of 6x. But now that we have it like this number and this number can be multiplied too, right? Numbers can be multiplied with numbers. In the other one, we didn't multiply them. It's not always necessary to multiply them, but if we want to if we want to simplify these to its maximum expression, we need to multiply these two. So if we multiply them, this will look like this: 3x squared plus 6 times 3, we have 18, cosine square 6x, sine 6x. And this will be our final answer. Okay? If you have questions here, you can pause the video and raise your hand. If not, let's continue. Now, let's see. What if we have something like this? Okay, so as you can see, we have also the chain rule in here, but in a different way. It's kind of in a different way. Give me a sec there. So this one here can be written like this. Right? So now instead of having a trigonometric function, we have a logarithm, a natural logarithm here. And let's remember this rule. And the rule of the natural logarithm says, I'm gonna write it in here. It is dy of the dx lau equals to u prime over u. Like this. Yes? So we need to get the derivative of u divided by u divided by all of this. Okay, so first let's get the derivative, and we say, okay, so the derivative is 1/2 x squared plus 4. Remember, we have here 1/2 minus 1. This minus 1 can be equal to 2 halves. So it is minus 1/2. If you cannot convert this, you can use a smiley face. This multiplying the derivative of the inner term, which is 2x. And this divided by what? By this one in here, the u. Remember, this all of this that we got in here, like all of this part in here, is just the derivative. Yes, is this the u prime. So this is divided by u, which is x squared plus 4 to 1/2. Okay, now this looks like this, so it means that we need to apply some algebra to simplify it. So if we multiply all of the numerator, we are going to have something like this. So we can say 2x times x squared plus 4 to minus 1/2, 2x x squared plus 4 minus 1/2. It looks like this, and this is divided by 2, and this is divided by x squared plus 4 to 1/2. Now we have a negative power in here, so it goes down. Down where? This is very important. Remember, this in here, these two are part of the same fraction. This one in here is different. This is an entire number. This is not a fraction, so be careful with that. Remember, you need to identify which one is a fraction and which one is entire number. So we can write this form like this: 2x divided by 2 times x squared plus 4 to 1/2, and now we change the sign, divided by x squared plus 4 to 1/2. Yes, and we add a 1 in order to apply the tortilla law. That looks like this. Once we have this, we multiply. It is 2x. Well, in this case, you can apply the reciprocal too. You can solve this by using the reciprocal if it's easier for you. If not, you can solve it by using the sandwich or tortilla law. So 2x times 1, 2x, and this is divided by 2. Okay, here we have 1/2 and 1/2. And remember, according to the law of exponents, in a multiplication, you add the exponents. Okay, so 1/2 plus 1/2 equals 1. Oh, I changed the color. X squared plus 4. And it looks like this. You have 1/2 plus 1/2. It is 1. You don't need to write a 1. It's okay like that. Now, you can divide or you can cancel these 2 with these 2. And that's everything that you can do. X over x squared plus 4. This will be your final answer. Remember, you cannot cancel this x with this because you have a plus in here. Yes, in order to do that, you need to have a multiplication. So you leave it like this, and this is your final answer. Okay, if you have questions in here, pause the video and raise your hand. If you don't have questions, let's continue then. So we're going to have a small exercise in here. I'm going to write some problems and you're going to answer them. Okay, so here you have the exercises. They are 4. They are kind of difficult, so take your time to analyze what you need to do in each one, okay? Once you finish them, let me know, and if you have questions, raise your hand. And that will be it for today. You can take a screenshot and answer these exercises digitally, or you can write them down on your notebooks. It's okay if you don't finish them, we can continue tomorrow.